Hi everyone, this is the voiceover of my series that I originally created for the overseas audience, and then I noticed some interest from my community here in Silicon Valley, so I decided to quickly translate it. In this episode, we continue improving our MES, Manufacturing Execution System, or CRM, Customer Relationship Management Software. Today we are going to build a state machine structure, set up global variable feedback, and explore several database functions such as database refresh list and database refresh table. My project is already open, and the project folder I copy VI Database Provider 2 and rename it to Database Provider 3. Then I drag it into the project, save all this project, and open it. Here's what the front panel looks like from the previous episode, and this is the block diagram. You can see the sub-VI we built in episode 4. If you haven't seen that episode, you can find the link in the description. Inside the timeout event, open the sub-VI, go to Windows Show Block Diagram. Here we need to replace the table name, change the string constant to a control, rename it to table from test station, and save it. Find it on the front panel of the sub-VI, connect it to the terminal, add terminal, we'll attach it at the top. Also, we had data and array side by side. I right-click, disconnect this terminal, move them closer, and save it again. Now the sub-VI icon is inactive. What we do is relink to sub-VI. Below data and array shift automatically, giving us room to connect. Here we connect the global variable database table. On the front panel, enable visible items, show tabs, go to the search tab, and from NXG style string, select string indicator. Rename it to table ordered by test station and expand it. Return to the block diagram, connect table ordered by test station to the database table global variable. Then copy the global variable on, change it to right, and create a false constant. The global variable on plus the false constant creates feedback. It turns off the global variable on from the database provider side. That means when the test station program sends the command, the variable switches global variable on there, then switches off here once the task is done. It's like a handshake between two lobby loops. This prevents writing the same data multiple times, only once. Now let's open the front panel full size, expand it, and let's make some adjustments here. I have a typo here, not tabled, table. Okay, let's move all of these elements to the search tab and transfer the table from the database DB tab. On the test station tab, bring in operator, table ordered by test station, tables, and the copied table from database. Now copy that table again. This will be table 2. Place it back on the database tab, but under a new name. Rename it DB table, database table, save it and resize so we could see everything clearly. On the block diagram, locate DB table and let's create an enum now. Go to numeric, enum constant, then edit items, insert. First will be initialize, second wait for event, move down, okay. Set this enum as default, make type default. Expand the while loop and event structure because we are about to add a case structure. Edit from structures, case structure, connect the enum to the while loop, replace it with a shift register and wire it to the case selector. Now, instead of true, we have wait for event and the second case is initialize. Inside initialize, we need to add 2 more cases. Let's go to open type default and open enum front panel, go to edit items, insert, move down and add 2 more cases, variables and global on. The order is initialize, variables, wait for event, global on. Save as control 1 in the sub-VI folder. Copy the enum inside the case structure, set it to variables and connect. After initialize, add a new case, add case after, variables case is created automatically. Wire the error line through, copy the enum again and select wait for event. On wait for event, we now need to work on the timeout event. Disconnect the wires and move the sub-VI and global variable on combination outside the while loop. Remove the case structure, rewire the error path, and inside place two enum constants. First, global on, second, wait for event. From comparison, choose select and connect. Let's check the definition of select function in context help. Select returns the value wired to the T input or F input depending on the value of S. If S is true, this function returns the value wired to T, true. If S is false, this function returns the value wired to F, false. And we can see all the inputs and outputs here. Context help always helps. We wired global on enum to true, global variable on to select, and enum wait for event to false. Okay. I closed context help and now I'm pulling the select connection through all the structures. Now I add the first case. In the case structure, add case after. Its name is created automatically, global on. Copy the enum constant, choose wait for event and wire through. Bring in the sub-VI and connect. So now we have cases in our case structure in the following order. Initialize variables, wait for event, global on. Within wait for event, we have the event structure timeout, global on, and global variable on, and wait for event enum working properly. Next events, radio buttons and power. We will expand the event structure now. For the stop button, set use default if unwired, save it and switch to variables case. Now we'll add new buttons. I already have them prepared. I'm going to simply copy and paste them. Okay, some mess on the front panel. Let's do it one more time. I said I'll simply copy, but it turned out to be not that simple, huh? No worries, I'll fix it now. Here you can see new buttons, DB table list, DB refresh list, DB refresh table. We'll work with them today. Next we have auto size, DB search, DB table columns, DB sort num, DB search, save DB table, index, delete, DB rows, DB columns. We'll cover them all in the next episodes. Because even in LabVIEW, multitasking is best done one button at a time. Let's align everything neatly. Find the buttons on the block diagram, open it fully, and move them into variables, except for DB itself. That includes DB table list, DB refresh list, and DB refresh table. Align to the left, vertical compress, switch to wait for event. After radio buttons, create a new event case, add event case, choose DB refresh list, okay? Compact it, lift it up, and set enum wait for event. Here we'll use a function combo from sub-VI. Open sub-VI block diagram, take the path to database and three functions, DB tools open connection, list tables, DB close connection. Copy them to our main block diagram, delete extras there and save. Back in the main diagram, inside the event for DB refresh list, paste all those functions, wire the error line and align everything. Create a property node, strings for DB table list, change to write and connect it to list tables. DB refresh list boolean goes inside too. Now our refresh button actually refreshes, which already makes it better than most web apps. Add another event case, DB refresh table. Here everything is the same. We copy enum, wait for event, and here we need the DB tools open connection function with the path to database MS access. Then we don't need DB tools list tables anymore. That is, we took from sub-VI the functions DB tools open connection and DB tools close connection. Now between them we will also put familiar to us combo of functions from connectivity database, choose DB tools select data, and also there from connectivity database we take database variant to data like this. Add DB tools open connection, then DB tools select data, and database variant to data between open and close connection. Create another property node for DB table list, this time value, and connect it through the error line to each database connectivity function. align, wire everything, and connect the DB table list property node to select data output type. Create an array constant, string constant, expand to 2D array, and connect to type on database variant to data. We have already done this in previous episodes. Also, connect DB table, change to indicator, to database variant to data. Finally, wire the DB refresh table boolean inside. Everything is ready here. Let's return to variables. DB table list we'll use later. Now, let's test how it all works. Save the block diagram, close it, and open TestStation 2. Run TestStation, run DB provider, keep both visible to watch data flow. On the test station, set the number of records, measure, and then send. Data is transferred to each table, and if a table doesn't exist yet, it's automatically created by the DB provider. Send, confirm, OK. The log shows data sent to TestStation 1, and the new table appears. Next, send to TestStation 2, confirm, data recorded there as well. Try TestStation 3, send twice, index changes, table updates. On TestStation 4, send a larger batch. We see multiple records. For TestStation 5, send 3 times, measure, send, measure, and send again. All data recorded properly. 5 stations, 5 tables, 0 bugs so far. Not bad, huh? Now go to the DB tab. Open DB table list, click DB refresh list. All created tables appear in the list. Select table 1, click DB refresh table, the function we worked on today, and all corresponding data shows instantly. Choose TestStation 2, DB refresh table, same thing. TestStation 3, refresh, data displayed. TestStation 4, we see around 70 records, all loaded correctly. TestStation 5, index 1 to 3, all there. Everything works together, smooth and synchronized. That's the moment when LabVIEW feels like magic, until you realize it's just smart logic and easy wiring. In the next episode, we'll continue enhancing the state machine and connecting more buttons using new functions from Database Connectivity Toolkit. Quick reminder, the source code for this episode is available in the video description. And remember, in engineering we trust, but in databases we verify. Thank you for joining Laplanda Tech. If you have any questions, please leave them in the comments. If you learned something new today, give this video a like and subscribe to learn more from upcoming episodes.